Hi everyone, this is Mr. Hall, and this is a really quick video about alkenes and their reactivity. In terms of the objectives from today's video, there are two things we're going to learn about. We're going to learn about the structure of alkenes, which will be able to describe them in the most basic sense, and we're also going to kind of talk about the conditions and the products of both combustion, which I probably won't focus on a great deal, to be perfectly honest, but I'll focus a lot about the addition reactions of alkenes with other things. So let's talk a little bit about the structure of alkenes first of all. So first off, the word saturated versus unsaturated. You should know already about alkanes and them being saturated. And basically what that means is that they're full up. So here's an alkane on the right, which is ethane, and you can see that it's full up because each carbon cannot fit any other atoms onto it. It can only make 4 covalent bonds, and each carbon has made those 4 covalent bonds. You can't put anything else inside it, so we say it's saturated. Okay, so as I just said before, each carbon already uses all 4 of its bonds to join to 4 other atoms. You can't put anything else into it. Now, alkenes are different because they're not saturated, they're unsaturated. And here on the right, this is ethene, and it's unsaturated because it has that double bond. Now, that double bond means that you could, in theory, if you reacted it with the right thing, break that double bond and add something onto that molecule to create something else. So it could support more atoms to it. Now, because you can do that, it's considered to be unsaturated. So that's the difference between the two. So alkenes, in any shape and form, they're considered to be unsaturated molecules. Now, the functional group of the alkenes, it's the CC double bond. And that double bond allows it to do the kind of reactivity that alkanes just can't do. Alkanes really aren't that very interesting. They can burn, they can do some stuff in the atmosphere that's, I mean, apart from that, there's not a great deal else that they can do. Whereas alkenes are a lot more interesting, and the CC double bond allows us to do reactions with lots and lots of different things. Now, alkenes form a homologous series, and what homologous series basically means is that they have similar chemical reactions, and they have a common general formula, which I'll come to in a minute. Now, these similar chemical reactions they all traditionally are able to do these addition reactions, which we're going to talk about later, and they all combust as well to some extent. Now, you do need to know about sort of the first 4 alkenes. Obviously, there's no methane because that's only 1 carbon, but you have ethene, which is C2H4, propene, C3H6, butene, which is C4H8, and also pentene, which is C5H10, and the structure is there at the bottom. Now, if you look closely, you can actually work out that the general formula for any alkene is CnH2n. So basically what that means is N is the number of carbon atoms in this particular case, and to work out the number of hydrogen atoms for that formula, you simply have to double it. So for example, if I had, let's say for example, you've got 12 carbon atoms, for example, then it would be C12, like so, and then H, and then you just have to do 12 times 2, which equals 24. Therefore, it's got to be H24, okay? And that's pretty much it. The reason why you don't have the +2, which you do get with alkanes, is because alkanes are always capped on the left and the right by those hydrogens, and that's effectively the +2, whereas with alkenes, you basically get rid of those because of that double bond that you've introduced to it. Okay, that's only if they have 1 double bond. Obviously, if they have more than 1 double bond, this general formula doesn't really hold, but in the interest of GCSE, you probably won't get anything like that, so no need to worry. So, in terms of alkene reactions, there are 2 types of reaction you have to be aware of. They do combustion, which is usually incomplete, and in incomplete combustion, just to remind you a couple of things you have to know, it's when you have limited oxygen. All right, so if you have limited oxygen, it means that you get incomplete combustion. A couple of other things about it as well is it gives off less energy. And also the products are different. So in normal combustion, you have carbon dioxide and water. In incomplete combustion, you still get water, but you also get carbon monoxide, which is CO, and you sometimes get soot, which is basically pure carbon, some particular forms, which you get as well, okay? The other type of reaction to do is addition reactions, and this is the one which is probably the one that you really need to know about. It's probably the trickier of the 2 to really understand. So, if you have an alkene reaction with a halogen and hydrogen, what happens is the double bond breaks and the 2 atoms from either hydrogen or the halogen connect onto the carbons that were part of that double bond. So for example, let's go through propene and chlorine as an example. So propene is 3 carbons, that's 1 on there, 2 and 3. We'll introduce the double bond here, and let's just draw the hydrogens in, 1, 2, 3, and that's got its 4 bonds. Here, that's got its bond there, and then this has got 2 hydrogens over here. Now, chlorine is just Cl2, okay, which I'll just draw like that. Now, in this reaction, this double bond breaks, okay, so I'm just going to show that breaks. And then what the chlorine atoms do is that they attach themselves onto the carbons that were part of that double bond. You don't need to know about the mechanism or anything like that. That's A level. You just need to appreciate that they do go into that spot. So if I was to redraw it, I'd still have my 3 carbons. I haven't gained or lost any. So there we are. And I've still got all the hydrogens, which I'm going to draw in. So one over here, and there. I've still got this hydrogen. So my advice to you would be to draw out the molecule as it was on the reactant side before you write the product. Now, I also have the chlorines I have to add as well, which is here and also here. And that's your product. Now, it's called an addition reaction because you're adding those atoms onto the molecule. Don't get too worried about writing the chlorine atom either there or there or there instead of there. That doesn't really matter as long as it's attached onto the correct carbon. Okay, don't worry about which of those it replaces. That's irrelevant. Okay, if we do a second example, let's do propene and hydrogen. So again, let's draw propene out, just like above, with all the hydrogens attached to it, like so. Now, because it's an addition reaction, again, that double bond's going to break. Let's just show what the hydrogen molecule looks like. It's H2, which is that. Okay, that's basically H2. And again, same thing happens. So this double bond breaks, and these 2 carbons can now accept other atoms to kind of go into the space that's been vacated. So this hydrogen is going to go over into here, and this hydrogen is going to go into here. Okay, so then what you're going to produce is still got the 3 carbons, and as I said before, I'm going to redraw the molecule pretty much as it was before the addition reaction itself. So it's got hydrogen here. I like kind of straightening up the bonds. You can notice at an angle there, and it actually is at an angle in real life. I like straightening them out just because it makes it clearer to see, and actually it's correct. And then I've got the 2 hydrogens which attach to those carbons, which will therefore produce this. Okay, so in terms of names, you don't need to know about how to name these type of compounds. These are called haloalkanes. Okay, this is a haloalkane. You're probably not too surprised as to why it's called that. It's because it's an alkane with a halogen on it. Sometimes they're called halogenoalkanes, but like you can just call them haloalkanes and that's fine. And you can see here this alkene that reacts with hydrogen creates an alkane, which in this case it's propane. So that's if you have addition with either a halogen, group 7 element, or hydrogen. Now with water, what happens is water is obviously H2O, and then the water splits with the hydrogen going to one of the carbons and the OH going to the other carbon. Now, because you've got an option of where it could go, and you don't need to know why, you just need to appreciate that this, as an example, only with ethene, because you've only got 2 carbons, so it doesn't really matter which carbon it goes on. So if I just draw ethene out, which would look like this, so here's ethene with your 2 carbons, hydrogen, hydrogen, and it looks like this. And then you've got water. Now, just to show it really clearly, water's H2O, as we know. I'm just going to draw it like this, just to show you've got the H bit and the OH bit there. So in addition, again, the double bond goes. One of these is going to go there, and the OH is going to go on to the other carbon there. And that reacts to form. Again, I'm going to draw it out again. So here are my 2 carbons, hydrogen here, one there, and one there. And then I've got the hydrogen on one of the carbons, which I'll put here, and then the OH goes over here. And if you put it on the other carbon rather than that carbon, it doesn't matter because, you know, in terms of the, you don't need to know it's A level basically, but it doesn't really matter where you draw it. Now, this is a new functional group, which some of you may not have come across before. So what you form here is an alcohol, okay? And that'll be in a future video, and you'll learn more about that later. Now, the other type that you might get, if they want to be really mean, is instead of reacting with water, they might give you a halide. So, for example, they might give you a reaction with HCl. Okay. Now, if you get HCl, the mechanism actually is very, very similar to what I've just showed you. So here's my alkene, which is ethene, like so. And if I react this with the halide HCl, which is basically this, again, my double bond breaks. The hydrogen goes over here, and then my chlorine goes over here, and then you've got your addition reaction done. So if I was to redraw it, here's 1 carbon, here's another carbon. I draw my hydrogens in first. I straighten the bonds because I want it to look tidy. There we go. Kind of had to squeeze that in there. And then chlorine will go onto one of the atoms. Again, it doesn't really matter which one it goes on because you're dealing with ethene and you don't have the kind of bigger issues that you get with a bigger molecule. And then the hydrogen goes there. And then what you create there, similar to what we had in the previous reaction with just the halogens straight up, is a halogenoalkane or haloalkane. Doesn't really matter the name. The only difference here is that you've got one halogen atom as opposed to two. So that's the reactivity. So I hope this video has been useful, and best of luck with all your alkene reactions.